Now, we'll have capacitance of three-phase, three-wire line with equal phase spacing. No? So, since this is a three-phase line, so we only need one phase, okay, for our calculations. Assumption, of course, is the operation is balanced. Okay, so balanced voltages. Okay, so we'll have balanced capacitances. So in this case, since single phase lang or only one phase is needed, so as if we are treating this voltage or capacitance like that of the single phase two-wire line. Okay, so pareho lang sila. Of particularly yung line-to-line capacitance or line-to-line voltage. Okay, so now your line, however, line-to-neutral voltage ito. Okay, so it's a different thing kasi dun sa single phase, that's merong line-to-line capacitance, meron ding line-to-neutral capacitance. But in this case, whatever the line-to-line of the single phase will be treated as a line-to-neutral of three-phase. Kasi nga, we'll only need to consider one phase. Okay? So, going back, so our voltage is given by this, and our capacitance to neutral is also this one. Okay? So, we always have to take note, this is farad per meter. Okay? So, yun ang default natin. In inductance, it's Henry per meter. So, this one is farad per meter. Okay? That's a three-phase, three-wire line. Equal phase spacing. Now, moving forward to unequal phase spacing naman. Okay? So, unequal phase spacing. Since three-phase ulit to, so only one phase will be needed to be considered. Okay, so it's the same thing with the inductance. We transpose, okay, in order to make the system unbalanced, no, because of this unequal phase spacing. Now, if you would only notice, no, again, this is capacitance to neutral. Okay, so what is only different from the previous three-phase equal spacing is this DEQ. Okay, so yung DEQ natin will simply be the geometric of mean of the distances between A, B, BC, and EC conductors. So, these are not new to you anymore kasi ito rin naman yung GMD of our inductance, di ba? Unequal phase spacing, di ba? Actually, if this will be like equal phase spacing, the same thing will happen kasi DAB is equal to DBC equal to DAC. So, parang D cube root of D cube will be D, di ba? Okay. So, yun lang. That's only the thing we need to consider here, no? So, 2 pi E over ln of DEQ over R. Okay? So, wherein our DEQ is simply the cube root of the GMD or the distances, product of the distances. Okay? So, that's for unequal phase spacing. Next is the stranded conductors. Okay, the equations used in capacitance calculation for solid, okay, either for single or three phase, no, are assumed to be applicable, no, for stranded conductors. So actually there will be like small error, no, parang if you use this versus the tedious computation ng for stranded, okay, there will be a small error, but those are just considered negligible. So therefore, i-adapt for stranded conductors, no, so we may use this formula, these equations. Okay, that is the same with the single phase. For halimbawa, this is single phase, so 2 pi E ln D over R. Again, this is a line to neutral. Okay, no, line to neutral. For three-phase with equal phase spacing naman, so ito rin yung gagamitin. Okay, 2 pi e over ln of d over r. No, yan naman yung gagamitin. Again, this is line to neutral. Okay, there will be no problem if you'll get the line-to-line capacitance, no? Kasi we know that the line-to-neutral capacitance is twice the line-to-line. Okay? Okay, so after stranded conductor, we'll have the bundled conductors. Okay? Here, I don't think there is a difference. Yes, there is a difference, no? But there is also a similarity in terms of the inductance, no? Okay, so let's try to find out. What we have here is the capacitance to neutral. Okay, so see, yeah. Okay, so it's 2 pi e over ln of DEQ DSC. Okay, actually, dun sa inductance, I think they are the same with DEQ. Alright, so simply in this case, no, cube root of DAB times DBC times DAC. So, for example, example of this bundled conductor, no? Okay, so that's the DEQ. Simply the DEQ. Diba? Which is also the same with inductance. Okay? Actually, this one is also the same. It's simply the same as the self. Diba? Ito yung GMR eh. Or the self GMD. Sorry for my writing. The self GMD. Okay? However, it will matter if the conductor is a 2-bundle, 3-conductor bundle, or a 4-conductor bundle, which is also similar kay inductance, right? But the only difference is that, what? The R. Okay? The outside radius R of the conductor replaces the GMR of DS. If you may also recall, yung DS natin in inductance is parang R prime, diba? R prime is something like that. Okay? We use R prime, no? R prime is R times 0.7788. But in this case, for capacitance, we only make use of R. That's it. So, your DSC for a 2-conductor bundle will simply be square root of RT. Diba? And so on and so on. Okay? So, that's capacitance of bundled conductors. If you would also notice, no, dun sa mga previous equations natin, so, we're making use of R. Diba? So, R. We're always referring to R. Okay, so for capacitance, so it's R instead of GMR or the R prime in the case of L or inductance. Okay, so you may want to take note of that. Next, yan. Here are somehow this is new to you kasi these are just also circuits to formula naman. So only that we have to be specific with the charging current here because kasi nga merong charges. Okay, so the charging current is injected, kumbaga napasok sa in the scenario, no, because of the current that is supplied to the transmission line capacitance, no. So if there is this if there's capacitance, no, merong charging current. Okay, yun yung association nila. Okay, now for single phase circuit operating at the line-to-line voltage, okay, the charging current is simply like this. Okay, so line-to-line, of course, to admittance, and yung voltage is also line-to-line. Okay, Now, please recall your your why. So, if ever na hindi natin memorize yan, no? So at least dapat we know how to derive this, no, out of this, no? So why is your admittance, no? So please do recall that, no? For what's next? For a three-phase line naman, okay, that has balanced sequence voltages, okay? The phase charging current, okay, phase A, phase B, phase C, no, charging current will be like this. So your admittance and of course the line to neutral voltage, okay. So we'll take now the capacitance and the line to neutral voltage, okay. Those are two different things, so for single phase circuit, so we have the line to line, no. Now for three phase, we can have the per phase quantities, okay, and then if we need the line to line quantities, so simply apply the square root of 3, diba? Okay, now there is also this reactive power, no. So it is assume that reactive power is delivered by the capacitance, no. So again, so may capacitance, there's a charging current, and there's also the reactive power being delivered by the capacitance, okay. Actually kaya nga siya naging power factor corrector, diba? Or useful for power factor correction. Okay, now the reactive power for single phase is this one, okay. By three phase naman, if it's a three phase, pero we might have considered the per phase quantities, okay lang, okay. Now for a three phase line, if we are after the total or the line quantities, it's also given here, okay. These are all I guess circuits 2 or AC circuit topics, so we don't have to dwell on that much, no. And I think we need to cut this off, this moment of this part, okay. So there's another video for the succeeding discussion.